Application of Schrodinger wave equation. Application of Schrodinger wave equation. Application of Schrodinger wave equation. First number. If potential energy is known, with the help of this equation we can calculate total energy E and wave function psi. If potential energy is known. If potential energy is known with the help of equation, with the help of equation, if the potential energy P is known with the help of equation, we can calculate total energy E. We can calculate total energy E and wave function psi. Total energy E and wave function psi. The second number is the atomic and molecular structure can be explained with the help of this equation. Atomic and molecular structure. The atomic and molecular structure can be calculated. Structure can be explained with the help of with the help of this equation. And the third number is, it is used for analysis of molecular motion. It is used for the analysis. It is used for the analysis of molecular motion. The fourth number is, transformational motion can be determined with the help of this equation in space. Transformational motion can be determined with the help of this equation in space. Transformation motion can be determined with the help of this equation in space. And physical significance of psi and psi square. Physical significance of psi and psi square. The first number is psi. Psi describes the wave behavior of the electron. It is called wave function, which describes amplitude of wave. It is half of the vertical distance between crest and tops. Psi is always finite, single-valued and continuous. Psi is always finite, single-valued and continuous. And second number is psi square. The physical significance of psi lies in the fact that psi square at any place is proportional to the probability of finding the electron there. Psi lies in the fact that psi square at any point, psi square at any point is directly psi square at any place is proportional to the probability of finding electron. The probability of finding electron there. Max Born suggested that in wave mechanics psi square be interpreted as electron density. Psi square varies from region to region. Psi square varies from region to region, and high values suggested greater possibility of finding the electron around the nucleus. The space over which there is a maximum probability of finding an electron is known as atomic orbital. The space over which there is maximum which there is maximum probability of finding an electron is known as atomic orbital. Psi square is also expressed as psi and complex conjugate psi. Psi square is also expressed as psi conjugate of psi, complex conjugate of psi. Hence, the particular value of psi which gives satisfactory solution of Schrodinger wave equation are known as eign function or wave function, whereas the values of E which correspond to these eign functions are known as eign values. Okay, thank you. Eign values and eign functions. Eign values and eign functions. Schrodinger wave equation has innumerable solutions. Many solutions are imaginary, hence have no significance at all. Only those solutions are significant which have certain properties as Schrodinger equation are significant. Schrodinger equations are significance which follows which follows certain properties. As the first number property is psi must be finite and continuous. Psi must be continuous and finite. Finite and continuous. The value of psi must be finite and continuous. The value of psi must be continuous and finite. Psi must be single valued. Psi must be single valued. Psi must be single valued. And third number is del psi upon del x, del psi upon del y, and del psi upon del z are continuous function of x, y, z. Are continuous function of x, y, z. X, y, z. Its value tends to 0 at infinity. Fourth number is its value tends to 0 at infinity. The value of psi tends to 0 at infinity. The value of psi tends to 0 at infinite. Only those solutions are significant which give certain definite and acceptable value of the total energy E. The acceptable value of given by a solution is called eign value. Only those solutions are significant. Only this solution are significant which give certain definite and acceptable values. And acceptable values of the total energy E, of the total energy E. The acceptable value of E is given by solution is called eign value. The acceptable values of E given by a solution is called eign values. And the corresponding wave function psi and the corresponding wave function psi, which which psi, which gives eign value of the energy, and the acceptable value of E given by a solution is called eign value, and the corresponding wave function psi, and the corresponding wave function psi, which gives eign value, which gives eign values, which gives eign values of the energy, is known as eign function, is known as eign function. Therefore, every function is not an eign function. Therefore, every function is not an eign function. Only those solutions are significant which give certain definite and acceptable values of the total energy E. The acceptable value of E given by a solution is called eign value, and the corresponding wave function psi, which gives eign value of the energy, is known as eign function. Therefore, every function is not an eign function. Okay, thank you. In the next, we study about physical significance of psi and psi square. Or only you listen the physical significance of psi and psi square. Psi describes the